Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this video we will be discussing about learning rate. So I hope that before coming to this video you are already aware about the in-depth understanding of how the gradient descent algorithm is working and how we are trying to update the value of M and C in order to find the global minima, in order to have a minimum error rate. So with that foundation in our head, let's get started. So as you can see on my screen very clearly, there are three plots which illustrates the gradient descent concept. If you remember, in our last part of the video, we have seen that how we can update the value of M and C. Do you remember that? I told you that at every iteration when we are trying to find the global minima, what we are looking for is at every point of time in linear regression, we are trying to update the weights. That is something that we are trying to do. And we have seen a formula to update the weights as new, for example, weight of M is nothing but what is the old weight minus eta times derivative of that error function with respect to M. And in the last part of the video, we have seen what is the value of this derivative of E with respect to M. So I will not go in that much depth. If there is anyone who is not aware about this derivative term, how we will be able to compute that, please do again watch the previous part of the video where I have completely illustrated this derivation in a very detail. Okay. The major focus of today's session is to talk about that, okay, what is this learning rate? So if you will be able to see, this learning rate illustrates that by how much quantity this value of M will be updated, right? That's why we are doing a multiplication with the learning rate itself. Similarly, the another weight of C, which is the intercept that we have in a best fit line, we told that it will be again equals to the old value minus eta times derivative of error function with respect to C. So this is how basically we try to update the weights, right? Even when we will discuss in future deep learning concepts, you will observe that this is how the weights in neural network is also updated. So now the important thing to understand here is that what is the significance of this learning rate? Even interviewers can also ask this question, that what is the significance of this learning rate? How will you able to determine? You will observe in maximum instances, experimentally it is being proven that the good value is 0.0001, right? So this is the experimental value, or you can say it's a hyperparameter. Means in maximum data sets, it is analyzed that which particular learning rate fits the best, right? So experimentally proven value, but it really depends on what kind of data you're working with. Now, the question is that what if we will take a very small value of learning rate? What will happen? What if we'll take the maximum exceeding value of a learning rate? And what if we take a significant value of learning rate? How it impacts? Or the question is, does that impact a lot or not? So the simple point here to understand, let's say I'm taking a very small value of learning rate. So can you see? This is the case where your learning rate value, or in other words, if I'll just signify it with eta on the same thing, this indicates a learning rate only. So you can observe that what will happen, it requires many updates before reaching to the minimum point. And you know, this is the minimum point. I hope everyone see that this is something which you can say is a global minima in this convex curve. Global minima in this convex curve. So what will happen that if you will take a very small value of a learning rate, it will take too many steps. It will do a lot many updates of the value of M and C to reach the global minima. So what will happen is that it will take too much amount of time in training your model. And this is where in training your model, this is where things will go wrong, because obviously you can't wait for days or months to get trained your model. You want key training should be done within significant amount of time. So the impact of learning rate to be very low is that it will take too much time for training, because at every point of time you are doing a very small change, and with a small value you're trying to update the value of M and C, right? If let's say, consider the vice versa case. If let's say I will choose a very high value. So this is the case for a very low value. Now I'm choosing a very high value. So what will happen? Vice versa. Now try to understand this concept also very well. If the value is too large of a learning rate, it causes drastic updates which lead to divergent behaviors. See, what I want is, I want to reach this global minima. Again, one of the same thing I'm trying to convey here. But let's say if you're trying to take a very bigger value of learning rate. So what will happen? Maybe you're starting with this. Here the error rate is very, very high. You have taken a very big value of eta, and drastically what is happening is you are trying to switch from here to, let's say, here, right? There is a drastic change in the error. Again, what happened is, let's say you are again trying to reach out, you are trying to take a bigger value of eta, and you reached somewhere here. So what is happening is, at any point of time, आप यहाँ पे तो आए नहीं, you haven't reached there, right? You are not able to reach the global minima that we really are looking forward towards, right? So this is the major problem here, that in this case, you won't be able to reach the global minima at all. And that is the major thing you want to achieve. So what will happen? It will keep on diverging, but the global minima it will not able to find out, because the rate at which your value of M and C is decreasing is very, very high, which doesn't make a lot of sense. So again, this is also not optimal. What is optimal? Taking just a right value. And that you will, or researchers will scientifically prove what could be the best optimal value for a given data set. Or there is a way to do the hyperparameter tuning, which when we will proceed ahead with the course, you will see I'm talking about few techniques, for example, grid search CV, random search CV. We will discuss how we can optimize our parameters. But definitely, if let's say you are saying that I'm taking now an optimal value of learning rate, so what will happen? It swiftly reaches the minimum point. So in this case, the issue of taking a too much amount of time will also be resolved. In this case, not getting an optimal global minima is also get resolved. You will move ahead with the significant steps, and definitely you will be able to reach to a global minima within desired amount of time that is provided to you. So this is the importance of learning rate. Learning rate basically signifies that by how much amount of value you are trying to decrease your value of M and C in order to decrease the overall error value, in order to find the global optimal minima in a gradient descent. So this is the overall approach that we have to follow. So this is the significance of learning rate. I hope now it is clear to everyone. So now I hope that you will be able to gain a complete in-depth understanding of how the learning rate works and what is the major significance of that. And in future, if let's say any interviewer will ask from you the importance of learning rate, so you can clearly explain the 3 cases here. When the learning rate is low, what will happen? When it is too high, what will happen? And what is the importance of having an ideal learning rate? So with this, let's end this particular video. I will see you all very soon in the upcoming video, where we will discuss another amazing concepts with respect to machine learning. I hope you are enjoying this course. I'll see you all very soon. Thank you so much.